In this lesson, we will talk about constraints. And for actually doing anything, you might ask yourself, what are constraints and why do we need them? Often, when you will be building your rigs, you will have to somehow limit or confine or expand some sort of functionality or to specify some sort of relationships and possibly exceed the limitations. And one clear example of that, enable this in my editor view, and one clear example of that limitation is actually a parent-child relationship. And let me tell you what I mean by limitation. So, as you probably know, if you create a parent-child connection with your object or objects and move or even rotate or scale your parent, the child will follow. And let me just pull that out from the hierarchy and you will see what I mean. So basically you are somewhat limited with this. Maybe you will want to create a different relationship. By different relationship, you could possibly want your child object just to follow the position or only to follow the rotation. So that's where constraints come in, and there are many types of constraints, and we will talk about a few of them. And many people who ask me have, especially colleagues, they have a real problem understanding constraints. The first issue you will encounter is you will not really be sure which object gets the constraint tag. I find it a little bit odd, but people do have that problem. So always the object that will be constrained to something gets the constraint tag. And you can find the constraint tag here under tags, character tags, and constraint. It's the first guy. And you will get this new tag, and here in the attributes manager you will see a lot of settings. And this is where people mainly get intimidated and are really reluctant to learn all the beautiful things that constraints can give them. Let me just position this somewhere in the center so we can see clearly. Actually, you see this parent and child text. I mean, I will just make a small addition to it. I will select both of those splines and apply a look at camera text. So if I orbit the scene in any way, it will always face those letters to me. It's just a workflow preference. So let's continue. We will select our tag here, and the first thing we will talk about is this PSR, which stands for position, scale, or rotation. So if you want to apply that kind of constraints, for example, if that classic parent-child relationship is not enough, or maybe you just want to position, scale, or rotation, or those objects that you want to create a parent-child relationships are somewhere on a different places in hierarchy, that can also be a limiting factor. So let's enable that PSR constraint, and we'll get a tab here. So go now into that constraint, and we'll see a few settings. Just expand this a little bit so I can talk about these settings just briefly. The first and the most obvious thing is add, and here you will add an empty slot where you will drag your target. Don't drag our parent guys, because we want to create some sort of a parent-child relationship between those two guys, and I'll drop the parent here, and let me enable just position and see what happens. And my child object simply disappeared, which is not entirely true because it's hidden inside this object. It completely jumped to the coordinates of this parent object. So if I just hide that parent for a second from the viewport, you will see that my child yellow sphere is still here. So this will lead us to these settings which says maintain region. So it's pretty simple to understand. It will keep its current position or rotation or scale until we do something with it. So this is pretty simple. So that means if I move my parent guy, the child will follow. But if I rotate or scale, nothing will happen. And that is behavior that I want. Maybe you will potentially want maybe just to enable the rotation, so you can create some sort of a planet with a little orbiting moon or something like that. This PSR has many applications. Here you can see some additional settings regarding specific position, specific axis, and you can use local coordinates and so on and so forth. You can, let me just get rid of this layer browser. So simply click on this little gizmo here and it will completely delete it. And you can add multiple targets here. That means if you add another object, let's just copy this parent, control drag it here, and you will get another one. And you can now, I'll drag the second one here into the target slot, and you can now define which one will that follow. Or maybe you will want that object to follow the rotation from this guy and position from this guy. So possibilities are endless. And if you want to blend and animate between them, or simply get additional control in percentages, how much will it obey from any target that it uses, you have this weight control. So I believe that is pretty clear and self-explanatory. So PSR, constraint, SR first, constraint. Next constraint we will talk about is aim constraint. So let me unhide those objects, and here you will see we have a simple arrow and sphere. And in this case, let's say I want to create a simple relationship, meaning that this arrow will always point to this sphere regardless of the position. So I want to be able to move this arrow anywhere, and I want it to point always at that sphere. So that's pretty simple. I will simply select that aim up vector. That's the name of the arrow. And I'll go here under character text and constraint and enable this aim constraint, which is really useful. Once again, we can find similar settings. So there is a maintain regional, there is some settings regarding the axis, so you can actually limit on some axis, and of course add target button. So we'll add a target, and now we are presented with this axis option. Some of you that watched volume 1 remember how much I insisted on really understanding the axis system. This is so crucial for rigging that is beyond words. So here you will decide which axis points to the target, and Z plus is this blue axis. So if I drop that sphere as a target now, then the arrow will rotate and will not point in the right way, and I have to choose the correct axis, and the correct axis is this Y, and in this case is plus. And if you're wondering why plus, the plus is always direction where the arrow points to. So just be clear on that. So this is plus, and in this direction is minus. Okay, hope that is really clear. I will delete this little guy and continue. I have to choose the correct, maybe I'll even lock this so I don't lose the settings if I enable the move tool or something like that. So use a little lock it. I will drag a target, and in this case that's this sphere. So put it inside and see what happens. Not much really, because nothing changed, but now if you move this sphere, you see the arrow is always following, and if you will be moving this guy, it will always point to, regardless of its position in the 3D space, it will always point to that sphere. And what is good is no matter how you try, the system will remain really bulletproof, and it won't change that relation. So you have once again a simple closed system that is really, really good. And it's versatile, it can be reapplied, it can be copied and reused and so on and so forth. So for what would this aim constraint be useful? For example, you could use it for eyes on your character. So you will have some sort of target object and the eyes will point to it. So you have really, really fast way of animating. Maybe you can, let's just drop this to 10%, this strength guy. So we will use 10% of that constraint. Let's try and move the target now and you will see something really neat. And you have to press play for that. And watch how it's becoming like some sort of a needle on the compass or something like that. It's really, really slowly catching up to this object. And in this manner you could, for example, animate fish. So fish would swim and slowly behave like it's underwater or something like that. I probably strayed out from the topic a bit, so let's get back on the track. The point is you can have really, really a lot of fun. Let me just try 1% and something here, and what if I drag this guy? It will really, really slowly catch up. That's more like a compass effect, something like that. And this aim constraint is really simple to understand. This next guy I will cover, this up vector, is a little bit different, and hopefully I will be able to explain it really good. Let me just stop this and I will revert the scene. So revert to saved, rather than doing so many undos, so we have a nice clean start. Let's add that constraint again, and this time you see, you want to remember that you have locked something. So otherwise, if you choose anything else, it won't display it in the attributes manager. So be sure to unlock it. This can drive you insane sometimes, trust me. So in this case, it's up only. Although if you enable it, it will see here up vector. So let's explain this. You can once again find those standard values, just like in aim constraint, and it's pretty much similar to aim constraint, just with a few different things. So once again you will add a target, and here you now have an up vector with some sort of an axis settings and the axis settings itself. So what does this exactly mean? And this means next, these two guys, this up vector and target, are connected. So you can actually use the target object as an up vector for your object. I hope this makes sense. So you will use the y plus axis. Once again, lock that manager. We'll use the y plus as an up direction, as an up vector, and the target will once again be the target we used before. So let's drop it in. And one difference is in regard to aim constraint is that you actually can lock the axis. You can lock the axis of rotation on desired here. So currently the z-axis is locked. This means if you change to rotate tool and try to rotate it around z, you won't be able to, because that axis is locked. But if you move the up vector, you will be able to rotate it through up vector too. So that basically means that the one axis that is locked here will be controlled with the up vector object. This is not really technically correct, but I really want you to understand these settings. And up vectors are mostly used to as stabilizers in a rig or in mechanical rigging, where you need to lock a certain object to rotate only on a single axis. So watch now, if I move this guy, it will only rotate on that single axis. Let's say I want to change it so this up vector controls only the rotation on x. Let's say x plus here, and now if we move this guy, you will see it actually rotates only on x. So it won't rotate in any of these other directions. You can test that constraint, so simply select your object and try to rotate it now on the x. It won't let you, but it will let you on other two axes. So it kind of simply lets this up vector constraint really gives you the option to lock a single axis and to control it with an up vector object, and you have the freedom in other two axes. I really hope I explained this well enough for you to understand. Unfortunately, my English is not that good that I can really present this exactly the way I want it, but I really hope you got it. And maybe this is a really good time to show you the use of null objects. They are sort of a helper objects, and since we already have that limit, so we can't rotate this on this x-axis, we can actually create a null object. So create a new null object, and let's drop it here, and if we put that arrow as a child of a null, I won't be still able to rotate this, but I can rotate the null object itself. See? I can exceed the limitations, and nulls are often used in hierarchies to provide some sort of functionality that is otherwise limited by a constraint or something like that. Some of you might ask, let me just pull this out of hierarchy. Some of you might ask, why didn't I simply do an Alt-G command, which will create a null on exactly the same space and position as this object? Well, simply because I wanted to have this axis all the way down here, so like this now. And just to make it more interesting, I will show you how to position that axis, that null object, to the bottom. If you select your move tool and have child objects, and you want to move just the selected object, the parent object, you can simply hold down the control key and you will be able to do that. You can of course press the P key and use the snapping features to snap that object exactly where you want. But beware, snapping doesn't work if you are going to snap parent object on child object. So let me show you that. If I bring up the snapping menu and enable just midpoint snapping and try to hold down the control key and snap to midpoints, simply won't work. I don't know if this is a bug or something else, but if I move that object out of hierarchy and do the same thing again, it will snap correctly. See how it snaps to that middle of this edge? Let's show it also here. Snaps to the center, once again in the center. So let's say we want it here. Don't forget to turn off the snapping and create that child-parent relationship once again. I'll zoom out just a bit to show you something that is really interesting. So watch what happens if I rotate this null. Watch what happens. I think you should probably recognize this. I'll undo that, and this can be a train setup. What really happens here is that this up vector is not really always aiming directly at the object. It just follows the general direction of that object. So it's really useful for some sort of mechanical rigging or something like that. And it also is versatile. So I could probably keyframe this, but I'll do an expression since we'll get much more control with that kind of setup. So instead of those manual keyframes, I really want to have a rotation control. So I want to build, let's say, a continuous rotation expression with some sort of expanded functionality. So once again, just to make things more clear, my null object is rotating. I'll do that, and I will unlock this, and here under null object I will say to display a circle, and maybe I'll add a color to it. So color on, and let's select some really visible color, something like this orangey. And now you will see that I'm actually rotating the null. The null object is rotating, okay? But that constraint here tells this arrow to point in that general direction. And since the axis of that up vector is here, it really orbits that null object. And if I rotate this and move this guy, it will once again do its thing. So that was just to show you briefly, it really points to that guy. So let's say we are building some train wheels and that metallic thing that it's connected. Is it a hinge? I really don't know. Someone will correct me later, but I think you know what I mean. So I'll build an espresso setup for this guy. So it rotates as I hit a play button here. So this is actually a really simple espresso. So tag Sina for the espresso, and could possibly dock it here, just to have some sort of a neatness in the scene. You can do whatever you want. You don't have to dock it, so something like this. And I'll drop my null object. Maybe it's a good idea to call it Tater. And you see it automatically updates here in the espresso. And just to make sure, I'll see what are the coordinates of this null object. So let me freeze it all, just to have nice clean zero values, otherwise we could run into some problems. So freeze all. It's also a good idea to freeze all on the target object. So let's select our rotator, and if we rotate it on this desired axis, we can actually see down here there is a pitch axis. So we will undo that. And here we will say coordinates, rotation P. So we want to drive this parameter. This parameter should receive some sort of instruction, some sort of data. And I want this progression of time. So as the time flows, it will drive the rotation. So that's really simple. There is a node in Espresso here under general. It's down here. It's called time. So I want the time to drive the rotation. They're really simple. And you can see we have a small issue here. And the issue is actually we have this set on -10, and the default value for all that is 0. So under 0, it will get no rotation at all. So this means the default value. So let's press play and see what we have. And it actually works, and it looks really nice. But the problem is we don't have a control, so we can actually control how fast this turns. We want a speed control here, and that is achievable pretty easy. So let's go back to -10. I will set the starting frame here to 0, so we don't have that rotation problem. And to solve this little thing, we have a nice node inside Sina 4D, and it's called math node under calculate. And please don't be intimidated, it's completely basic math. And let's connect those guys. We actually have two inputs here, and the input 2 will be our control, our speed control. So if you press play now, this is what will happen. And currently the function is set to add, and if I increase this number, it will just add one increment of that rotation, but the speed will stay the same. So this is not good. Let's go back. And what I want to set as a function is multiply. We want to multiply that increments. So every time we increase the number, it will be double the speed. So let's try it out. Let's press play here and you will see nothing will happen since this is set to 0. If we put this to 1, it will rotate according to the speed of 1. If we set this to 2, it will go faster. 3, even faster. 4, 5, you can go really crazy with that and control this rotation speed with this guy. You can also pull it in the viewport and have your custom control here. You can even create a user data slider, so you can actually have a slider that is named accordingly, because this met input 2 and 5 could really give you a headache later once you forget what was it all about. So maybe I'll just mention this maybe parent constraint. If you apply this parent constraint but on this target object, you can actually say to this sphere that this arrow is its parent. So you can create another relationship so that sphere would really follow the arrow as it rotates. But you can do a maintain original command, so it will always keep the distance. I really don't see a need to show that the parent constraint is pretty self-explanatory. The next guy we will talk about is this clamp constraint, which is really powerful. I will just revert to saved, and instead of deleting this guy, I will just go here under window layout. I will tick again startup layout, so it will give me my standard layout. I want to show you the clamp constraint now, which is really powerful and versatile and has so many applications, and there are many different various modes within that constraint itself. This is best shown on the example. So let's open this one up. First we will unhide its visibility in the viewport. And it's a little bit big, and we'll just hide this landscape object. That will be for another example. So let me just zoom out a bit, something like this. I will add a constraint tag to this sphere because I want to clamp it to this spline. So let's go text character constraint, and we will enable the clamp constraint. And here in the settings we have just an add button. So we will add a target, and our target will be the spline. You can see something happened. You see this little red guy? This is the actual clamp. And that clamp is a distance from the actual axis of this object to the spline itself. And it draws the clamp to what it's set here. And here you can find really some various modes. So let's change this to a spline, and we'll see a change. So now, while we are in spline mode, we clamped this sphere to a spline, and we clamped it in this mode. So we want it fixed on this distance. Let's put a distance to 0. That will mean it will completely be 0 distance from this axis, because all constraints and objects are calculated from the axis. And I mentioned this in volume 1, and it's really important for you to understand that. So if you try to move this sphere, it will move on the spline. It will be constrained or clamped to a spline. You can change this mode to say, let's say, minimum. This will mean that no matter where you move the sphere, the minimal distance that will be kept is 15 centimeters. This means it won't get closer than 15 centimeters to that spline. That is a complete opposite setting. So if I put this to a maximum value, this will mean you cannot pull it more than 15 centimeters from the spline. And this has so many applications, and This is really, really powerful. I'll talk about this align and as functions a little bit later, because this is not really a good example for that. And you can just explain this lock position. It simply means it will lock the clamp. You will be able to move the object, but it will be clamped to a certain point. And let's change this to minimum, and I will show you something. And you have possibilities to add numerous targets. So let's copy that spline once more and pull it just a bit here. And I accidentally copied this sphere, and I want to delete this one, and I will lock this constraint option here, so it's locked, so it's always on, and I will add another target and drop this new spline here. And it always by default calculates the current distance from the object that will be clamped to another object. So now you can see it's currently in the origin mode, so it will create a clamp to the origin of the newly created spline. You can of course change these other values and you will get really interesting results. So let's put this also to 15 and try to move our sphere, and let's see what happens. It won't let us exceed those minimum values here. Currently it's in a fixed mode, so it means it will be fixed distance. Contrary to that, if you set that to minimum, you will have really small area to work with. You can see I really cannot move below that certain value, and you can adjust the weight. That means basically the amount of influence of each of these targets. Hope I haven't lost anyone with this. And so let me show you another type of constraint, and we'll delete this spline, guys, and also this constraint we made, and I will enable the visibility of this landscape object and show you something that is really interesting. I want to show you the surface constraint inside the clamp constraint, so I'll just fold this, it's kind of in the way. We'll talk about this bounds constraint within the clamp constraint next. So let's create a new constraint, and character text constraint, and you see this is locked. Always remember that. Let's enable the clamp constraint. Okay, so we will add a target, and in this case the target will be the landscape, since you can see it already draw a clamp. Since I want this sphere to really travel on the surface of this landscape automatically, so it automatically adjusts its distance according to the surface itself. Since I want it to be completely on the surface, I will set the distance to 0 and set here surface option. Once again, that rule that C now4D calculates everything from the axis itself, and you can see that I just pressed the S key. It really zooms in on the object you currently have selected. I'll zoom out just a bit, and if you want this to lie exactly on the surface, you have to put the axis all the way down to the bottom of the sphere. So we have a axis center tool here under structure menu, and simply, as you can see, this is Y plus. So drop it all the way to minus 100% on the Y. So it means it will go all the way into the negative Y. So hit execute and see what happens. It automatically pops on the surface. And try to move this now. It travels on the surface, but it really doesn't orient itself according to the surface. Let's see that. It will be more clear if I... Let's do something really quickly. I will just squash this down and something like this. Don't mind the artistic bit now. So imagine this is a snowboard. It really looks like a surfboard, but it will serve the purpose. So here I will talk about this align and as what mode. If I move this guy now, just lock it. You can see how that is useful. It really speeds up things. Now it really moves, but it kind of floats. So when it comes here, it should really tilt this side over, so it appears more natural. And you can do that with this as option. So you can put the constraint mode here and it will orient itself, but it will go wild in many situations. Better option is this normal. It will be a little better, but there is a sudden pop. You see, this is not really realistic. The best thing here is this Fong normal. It has that nice fluid transition between two states, and basically what it does, it uses the Fong normal information that you have built in on the object itself. So that will be the most smooth option. This align simply tells which of the axes will be aligned to the surface. So now instead of manually keyframing all those things, for example, maybe you will want an animation where the surfboard goes here and it jumps, so you can simply animate the strength. So you can put it in the air for some time, land it, and again activate the clamp, and so on and so forth. All these guys that have this little sort of a beveled cube or even a sphere are animatable, so you can imagine the power you have at your disposal. This surface constraint really has numerous applications. For example, you can put trees on the landscape. You can maybe create maybe even create a tear on character's face, or you can really imagine multiple applications. Let me just delete all that so we can talk about next type of constraint within the clamp constraint, because clamp constraint is really powerful. It has many modes. So let's turn on the visibility here, and I have a really simple representation, but it will be the most logical thing to understand. So let's put a constraint on this sphere guy. Once again, unlock this or you won't be able to see anything. Enable the clamp constraint, add a target. The target will be our boundary object, and we will set the mode to bounce. Now if I try to move my object and possibly set this to 0, distance to 0, you will see what happens. I can move within the object, within the volume of the object, but I cannot move it outside. So it confines the object into another one, into a volume. You can also enable that maybe constraint in this case, and you see how it also orients towards the normals that are coming out from these polygons, and you can do a axis command just to put it exactly on the inner surface, so something like this, and in this case it should be all the way to 100. So once again you can choose the axis that will be aligned to an object that this one is clamped to, and this can be really useful. For example, let's say you want to animate a fly captured under the glass or something like that. It really also has multiple applications. Let's talk about next constraint we have. I will delete this bounce guys, so always get rid of what you are certain that you will not need. And I just press the H key and it frames all in the viewport. This guy is familiar from previous lessons. I will just here under window layout command manager, I will find my reset position script, and simply for convenience I will drag it here in the viewport and position it somewhere around here. And now we are really discussing a lot of theory and the technical aspects and how things work, but this is really crucial for you to understand rigging, because you won't be able to rig absolutely anything properly if you don't get technical knowledge under your fingers. And all this we are doing now in this lesson we will apply practically on real models. We will rig model and set up the expressor for arm, for a leg, for a hand, and so on and so forth. So it's really important not to skip these lessons because you will get lost if you will try to watch a video later and really don't understand what is going on. We are going to solve a little problem, and this will be somewhat of a practical application of a constraint. In this case, we will also use a clamp constraint. Let me just check the coordinates of this guy, and it's okay. And let's create a constraint on this joint goal, because we'll most certainly create a character at some point, and you'll probably want to animate it, create walk cycles or something like that, but you will encounter a problem where your foot goes into the ground, into some sort of pavement or dirt on anything you created, and you would want to create an automatic setup for it. So basically that is called a foot clamp. You will want to constrain the foot not to go through the ground. This is pretty simple in Sina as opposed in some other applications, and here we will just create a new constraint, new clamp constraint, add a target, and add this plane or ground object or whatever you have. And as we progress to the videos, I will really avoid talking too much about settings that I've explained previously. I will just tell I will set this to do this and do this. I hope this is not really too intimidating, so we will start with it right now. So here I want this joint goal to be constrained to a plane. I dropped the plane as a target, and I will put a minimum here. I will select the actual plane of which two axes will be used, and in this case that is, let's see, that is x, z plus, and I believe that's it. Let us try that. I will pull firstly downwards this guy. I will hide the axis because you could actually then see the plane itself, and I can turn off the x and z, so if I move something here, it will just move in the y direction. So watch what happens now. It will move that joint goal. It won't do it in the opposite way. So anytime your leg encounters this surface, it won't go through. Just reset it to position. So let me just drag out this plane from the hierarchy, because if I will move the foot clamp, it will also move the plane itself. So let me show you that. If I move this now, it will enable my axis in this case. And see, if I move this now, it will move the plane, and that is what I don't want. And the reason why I'm doing this is to show you that it will work the opposite way. You see this? It won't let you go through this plane object. This is a very useful type of constraint, and it also has many types of applications. It's absolutely crucial to understand them to be able to mimic any type of real-world behavior, so you can copy it, you can really transfer that into any constraint. So basically almost any type of behavior you want to create that you can see in the real world can be done with constraints. And here we are again. So we just have two more constraints we have to look at, and they're pretty simple, but I think it would be good to check them out. So character constraint, and first we'll talk about this mirror constraint, which is really simple, and you can see we have some settings that apply to all constraints, and I will add a target, and in this case this will be this violet sphere, and I will check this position, and we'll see what it does. It's really simple. So it mirrors the behavior of another object. So this one mirrors the behavior of the violet sphere. So it's that simple. You have some options here you can play with. For example, you can enable rotation. You can even set where will be the origin of mirroring. You can even use an object for mirroring, so that can be useful sometimes. And of course, you have a weight option here once you insert that object, and so on and so forth. Really simple thing. You can actually, here under basic tab, you can turn off that mirror and talk about spring constraint, which is really fun to play with. And of course you add the target. Once again, drop that violet one as our object, and I will decrease the length. It will take the current distance between objects axis into account. So that's this number, and we will lower it and see what happens. And actually nothing happens, and that is because we haven't activated any of these settings. So let's go back, and you see a little mistake. Everybody makes mistakes, so let's enable the position and hit play and try again. And let's see that it springs in the center of that violet sphere. So if I do some sort of a length and set some distance apart, so if I set exactly this size of the sphere here, spheres will be touching. So instead of this play button and reversing and seeing the effect, because sometimes you cannot really see that effect. It looks like it's doing something, but it's actually too slow. And by too slow, I mean this. I will enable this under Character Manager, Auto Redraw, and I will redraw it every 1 millisecond, and you will see the difference. See, it's much more dynamic now. It's much more realistic in motion. So basically, this constraint acts like a spring. You can even play with this stiffness value, and maybe you can see it will always follow in the springy manner. So you can create some sort of crazy effects, like maybe bouncing the little ping pong ball with a racket and stuff like that. So it's really fun stuff. So if you, for example, drop this drag to 1, you will increase the dynamic effect in the constraint objects or something like this. I could do this just for fun, so I hope you really get those constraints now. For example, one application could be you could animate this and have like some sort of a nuclear animations where you have an atom and some sort of electrons and so on and so forth. So it can be also used in many applications. So let's go with our next lesson.